This is the fourth lesson of Topic 18. In this lesson, we're going to learn how to get an equation of a circle from what is called general form into standard form. Standard form is the one that we should be familiar with at this point. So in order to do that, we're going to have to use a process called completing the square that you learned in Algebra 1. So before we do that, we need to understand that there are lots of different ways that we can write equations of functions. So number one is a review from Algebra 1 on graphing linear functions. So of course they're going to graph to be a line. And these are the three different ways that a line can be written as an equation. The first one is slope-intercept form, y equals mx plus b, where m is your slope and b is your y-intercept. So if I was to graph this line, the y-intercept, my constant, is 6. So I would go on the y-axis to 6 and place a point. The number in front of x is my slope. And remember, slope is rise over run. So 3 is the same thing as 3 over 1. So from this point, I would rise 3 and run 1. Now, since I went up and right, I could have the same effect by going down and left. So negative 3 over negative 1 is also a positive 3. So I could go down 3, left 1, down 3, left 1, down 3, left 1, and just get other points. It just makes it a little bit easier to draw the line. So this is the graph of that equation that's written in slope-intercept form. Now, the next equation is written in what's called point-slope form. Point-slope form is given here, y minus y1 equals m times x minus x1. It's called point-slope because it uses a point on the line and the slope. So the point is the x1 and the y1. Notice the subtraction in front of them. So that makes the coordinates actually have the opposite sign of what is in the formula here, or in the equation. So x plus 1 is the same thing as x minus negative 1. So that tells me the x of the point that I'm trying to graph is actually a negative 1, because x plus 1 is the same thing as x minus negative 1. So my x-coordinate is negative 1. Now the y-coordinate, what is being subtracted from y? A 3. So again, just like with a circle, these signs are actually liars of the signs of the coordinate. So this line goes through the point negative 1, 3. Well, here's that point right there, negative 1, 3. The slope is the number in front of the parentheses here. So just like the slope of the previous equation, my slope is 3. So as you can tell, I'm going to get the same exact line as I already have graphed. So these represent the same line, they're just written in a different form. The last form is called standard form. So standard form is ax plus by equals c. We cannot really tell anything from the equation itself, but standard form is good for finding your x and y intercepts. And so in order to find the x-intercept, we have to understand that every point on the x-axis has a y of 0. So if I replace this y with 0, that whole term would go away, and I would be left with 3x equals negative 6. Well, I can solve that for x by dividing both sides by 3, and I get my x-intercept has to be negative 2. There's that point right there, negative 2 on the x-axis. To find the y-intercept, I need to understand every point on the y-axis has an x of 0. So if I replace the x with 0, 3 times 0 would still be 0. So this term goes away, and I'm left with the equation negative y equals negative 6. So I could solve for y by dividing both sides by negative 1 and find my y-intercept is positive 6. So if I went up on the y-axis to 6, there's that point. So all I have to do is connect my x and my y intercepts, and I get the same exact line. So the point of number 1 in your notes is just to understand that all three of these equations represent the same line, just written in different forms. Well, circles also have different forms that they can be written in. So let's look at number 2 in your notes. It says, what do you notice about the three graphs? Hopefully we notice that they are the exact same line. So we were just writing that same line in three different forms. So just like there are different forms of linear equations, we have different forms of circle equations. We have been focusing on what's called the standard form of a circle. X minus h squared plus y minus k squared equals r squared. Remember, the information that we can determine from this form of the equation of a circle are its center and its radius. So remember, the center of this circle would be +1, +2, the opposite of these signs. And this number is the radius squared. So we'd have to take the square root of it to know our radius is 3. So you can that's not really the answer to number 3, but you can kind of write that off to the side here. The center would be the point 1, 2, and our radius would be 3, the square root of 9. So we could graph that circle by just plotting the point 1, 2, and then remember the radius allows us to graph 4 good points. From the point 1, 2, we would go 3 units to the right, 3 units up, 3 units to the left, 3 units down, and that gives us 4 points to draw our circle with. So what we're going to do is we're going to take this equation of a circle that is in standard form, and we're going to write it in general form. And the way to get it in general form is to just expand out those binomials squared. So remember, a common mistake students will have is they think all they have to do is square that x and that -1, and that's not correct. Remember, anything squared is that number times itself. So I could write x minus 1 squared as x minus 1 times x minus 1. And I could write y minus 2 squared as y minus 2 times y minus 2. And that's equal to 9. Well, remember, when you have a binomial times a binomial, you have to fully distribute. There's 4 multiplications to do. So I have to multiply the x times the x and by the -1. And then I have to multiply the -1 times the x and the -1. So x times x, remember, add those exponents, is x squared. X times -1 is -1x. -1 times x is another -1x. And -1 times -1 is +1. Plus, I have to distribute here. Y times y is y squared. Y times -2 is -2y. -2 times y is another -2y. And -2 times -2 is +4. So now to get it in general form, I just have to kind of combine like terms and get things in the right order. So I could combine the -1x's together and the -2y's together and write that as x squared minus 2x plus 1 plus y squared minus 4y plus 4 equals 9. We're almost in general form. General form puts the x squared and the y squared at the beginning of the equation, then the x term and the y term, so -2x minus 4y, and then it gets all the constants together on the left side so that your equation is set equal to 0. Well, this 1 and 4 are on the same side, so they would combine to get 5. But to get the 9 over there, we would have to subtract 9 from both sides. So we would have 5 minus 9, giving us a -4. This is the general form of the equation of the circle. And so you will see that here, exactly what we got compared to the standard form. Now, the general form is really not user-friendly. We really can't tell a whole lot about the circle from general form. So we don't usually go from standard form to general form. What we really need to know is how to go from general form to standard form, because standard form is the one that we can tell that where the center is and the radius, and we can graph the circle. So we are going to review a process that will help us get from the general form to the standard form of a circle. We're going to skip question 4 in our notes. That's just not needed today, and look at question 5. So it says match each perfect square trinomial to the equivalent expression written as a square of a binomial. So a perfect square trinomial is simply a 3-termed polynomial. That's what trinomial means. It's 3 terms. And so you can see all of these are 3 terms, so they're all trinomials. These are perfect square trinomials because when you factor them, you get the same binomial times itself. So we've practiced factoring many times this year. We know that when the number in front of x squared is an understood 1, we simply have our first terms as the square root of x squared, which is both x's. X times x would give me x squared. To get the other term in the binomials, it has to be numbers that multiply to get the c value. So we have to have numbers that multiply to get 4. Well, the only numbers that multiply to get 4 are 1 and 4, 2 and 2, -1 and -4, and -2 and -2. Those are the only possibilities of numbers that multiply to get positive 4. But we're looking for the pair that adds to get the b value, which is a positive 4. So the only ones that work there are the 2 and 2. That's why this is a perfect square trinomial, because both of those binomials were exactly the same. So we can write this as simply x plus 2 squared. So this trinomial matches up with x plus 2 squared. So here, very similar, right? We still want numbers that multiply to get 4, so it's still these same pairs here. But this time we want them to add to get -4. So now we're using the -2's. So this would match up with x minus 2 squared. And then the next ones, these are y's. So here are our possibilities here. We want numbers that multiply to get 25 and add to get -10. So that means the two numbers have to both be negative because they have to multiply to get a positive, but add to get a negative. So the only one that's an option here is this one. And does that work? Does -5 multiplied by -5 to get positive 25? Yes. And does -5 add to -5 and get -10? Yes. So this factors to y minus 5 squared. If you factored out y minus 5 times y minus 5, and you did all 4 multiplications, you would get this trinomial here. So the last one, we want numbers that multiply to get 16 and add to get 8. Hopefully you know that those have to be positive 4s, so this would match to this binomial squared here, y plus 4 squared. Now I want you to notice something. What it matches to, this number 2, this number -2, this number -5, and this number 4, those numbers are all half of the b value. Half of 4 is 2. Half of -4 is -2. Half of -10 is -5. Half of +8 is +4. That's just a helpful thing to recognize when we are going through the process we're learning today, known as completing the square. So we are going to practice completing the square with a quadratic. So this is a review from Algebra 1. You may or may not remember this, but we've talked about this year that anytime you see that x squared, that means you have a quadratic. When you graph a quadratic, you get a parabola, either one that's opening up or one that is opening down, right? So the open up or open down is always determined by the a value. A is the number in front of x squared. If the number in front of x squared is positive, your parabola opens up. If it's negative, it opens down. So ours is an understood 1, so we would have an opened up parabola. We want to get this quadratic from what is called the standard form into what is called vertex form. So the standard form of a quadratic is ax squared plus bx plus c equals 0. We want to get it in vertex form, which is a times x minus h squared plus k equals 0. And the process to get from here to here is called completing the square. So the first thing I'm going to do in completing the square is I'm going to write the x squared plus the 6x and then leave a blank. And then I'm going to put my constant on the left side and have this equation set equal to 0. So in order to have this set equal to 0, I'm going to have to subtract 5 from both sides. So what is 11 minus 5? It's 6. But I'm not putting the 6 here. Okay, I'm leaving a blank in between these two terms and that constant. The reason why is I'm going to create a perfect square trinomial here. A perfect square trinomial, remember, is one that factors into the same binomial times itself.